Hello there, study buds! Are you ready to explore the world of algebra? This is your study bud John, and today I will discuss to you the topics which are, voila, variables and algebraic expressions, the real number line, comparing and ordering numbers, and absolute value. If you want to learn more about them, please keep watching. Variable and algebraic expressions. Let me start by defining what does variable and algebraic expression mean. A variable is something that can change and represented by a lowercase letter. Most common is x. Or more specifically, it is a letter that represents a certain number or value. For example, x plus 7. X here is a variable. An algebraic expression is a mathematical expression that consists of variables, numbers, and operations. In such cases where algebraic expressions contain more than 3 unlike terms that may comprise of exponents which are added, subtracted, multiplied, and divided. These such expressions are generally called polynomials. There are 3 types of polynomials, namely monomial, binomial, and trinomial. Monomials are algebraic expressions that contains only one term. 2x plus 5x plus 10x is a monomial because when we add the like terms, it results in 17x. 4t and 2pq are also examples of monomials. Binomials. With the prefix bi, we can tell that the binomials are the algebraic expressions with 2 unlike terms. For example, 3x plus 4x squared is a binomial, since it contains 2 unlike terms, that is 3x and 4x squared. Likewise, 10pq plus 13p squared q is a binomial. Trinomials are the type of algebraic expressions with the 3 terms unlike, thus the word trinomial. For example, 3x plus 5x squared minus 6x cubed is a trinomial. It is due to the presence of 3 unlike terms, namely 3x, 5x squared, and 3x cubed. Likewise, 12pq plus 4x squared minus 10 is a trinomial. And now, let's learn how to evaluate expressions. The first form of evaluating expressions is used when we know what is the value of each variable in the expression. Remember that every time you evaluate where the variable is given, just substitute the variable and follow the parentheses, exponent, multiplication, division, addition, and subtraction, or PEMDAS. For example, 4 plus x, for x is equal to 3, replace x with 3, then add 4 plus 3 is equal to 7. Another example, a open parenthesis b plus 7 close parenthesis. For a is equal to 3 and b is equal to 2. Replace a with 3 and b with 2. Solve what's inside the parenthesis, which is 2 plus 7. 2 plus 7 is equal to 9. Then, we'll multiply. 3 times 9 is equal to 27. Another example, 2x plus 3, for x is equal to 7. Feel free to pause the video if you want to solve this problem. So, replace x with 7 and multiply 2 with the value of x, which is 7. So, 2 times 7 is equal to 14. Then we add 3. 14 plus 3 is equal to 17. You see, it's easy to evaluate expressions when we know the value of the variables. But what if we don't? In this case, we'll only simplify what we can and leave what we can't. Things to remember during simplification. There will be no changes in the variable during addition and subtraction, unlike multiplication and division. For example, 3x plus 2x is equal to 5x, while 3x times 2x will be 6x squared. So, how to simplify? Combine like terms. Like terms are terms with the same variable. For example, 7x minus 4y minus 9x plus 7y. Put like terms right next to each other. 7x minus 9x minus 4y plus 7y. Then solve the numbers before like terms. 7x minus x is equal to negative 2x, while negative 4y plus 7y is equal to 3y. So that is our final answer. Negative 2x plus 3y. So here's another example. 8x squared plus 3x plus 7 minus 2x squared plus 4x minus 3. Feel free to pause the video if you want to solve this problem. So first, we'll combine the like terms. 8x squared minus 2x squared minus 3x plus 4x plus 7 minus 3. 8x squared minus 2x squared, that will be 6x squared. Negative 3x plus 4x is x, and 7 minus 3 is 4. So our final answer will be 6x squared plus x plus 4. Sometimes there will be a set of parentheses that makes simplifying an expression a little bit difficult. So here's another way: distributing or distributive property. Using this property, we multiply the term outside the parentheses by each term inside the parentheses. A, open parenthesis, b, plus c is equal to ab plus ac. For example, 4, open parenthesis, 2x minus 8, close parenthesis. Multiply each term inside the parenthesis by 4. 4 times 2x is equal to 8x, and 4 times negative 8 is equal to negative 32. So our final answer will be 8x minus 32. So here's another example. Negative 7x, open parenthesis, x, minus 4, close parenthesis. So feel free to pause the video if you want to solve this on your own first. So we multiply each term inside the parenthesis by negative 7x. Negative 7x times x will be negative 7x squared, and negative 7x times negative 4 will be positive 28. So our final answer will be negative 7x squared plus 28. So remember, always be careful with your sign. Distributing through parentheses and combining like terms can be combined in one problem. Here's an example. Negative 10 minus 4, open parenthesis, n, minus 5, close parenthesis. What do we do here? So according to the order of operations, we need to multiply or distribute first, then add or subtract, combine like terms. In short, we distribute, then combine. So negative minus 4, open parenthesis, n, minus 5, close parenthesis. So distribute negative 4 to the terms inside the parentheses. So it will be negative 10 minus 4n plus 20. So combine like terms. Negative 4n plus 10 is our final answer. So next example, we have 3x minus 2, open parenthesis, 4x minus 5, close parenthesis. Distribute negative 2 to the terms inside the parentheses. So negative 2 times 4x will be 8x, and negative 2 times negative 5 is equal to positive 10. So our next step will be 3x minus 8x plus 10. So let's combine the like term. So our final answer will be negative 5x plus 10. Rational numbers and the real number system. So real numbers. It is a set of rational and irrational numbers, and the real number line is a way of representing it. The number to the right of the zero are positive numbers, and the numbers at the left are negative. The rightmost numbers are higher than the leftmost numbers. Comparing and ordering numbers. When comparing and ordering numbers, change all numbers into the same type of number when needed, and then compare using the number line. For example, negative 17 and negative 16. When comparing the numbers, always remember the rightmost number is higher and leftmost is lesser. So, negative 17 is less than negative 16. Another example, 1 over 6 and negative 0.83. By seeing this example, we can already tell which is greater and which is lesser just by their sign. 1 over 6 is greater than negative 0.83. More examples. 1 over 5 and 2 over 7. So first we will find the LCD, or the least common denominator, since these are dissimilar fraction. Remember to multiply the number from your denominator to your numerator too. So 7 over 35 and 10 over 35. Which means that 2 over 7 is greater than 1 over 5. Absolute value. It is basically the distance of x from 0. Example, find the absolute value of x when x is equal to 5, x is equal to negative 10, and x is equal to negative 12. So, the absolute value of 5 is 5, the absolute value of negative 10 is 10, the absolute value of negative 12 is 12. As you can see, the absolute value of a negative number is just its positive version. But always remember that absolute value is not the positive of a negative, neither the positive of the positive, but it is the number of units from the zero. Solving linear absolute value equations. When equations with absolute value, we can end up with more than one possible answer. This is because what is in the absolute value can be either positive or negative, and we must account for both possibilities when solving equations. Example, the absolute value of x equals 8 means that x can be equal to 8 or x equals negative 8. Another example, 5 plus the absolute value of x is equal 9. So first, we subtract 5 from both sides of the equation, which leaves us to the absolute value of x equals 4. So it means that the x can either be negative 4 or 4. Another example, negative 4 absolute value of x is equal to negative 20. Feel free to pause the video if you want to solve this on your own. So, first we divide negative 4 from both sides of the equation, which leads us to x is equal to 5, which means that x is equal to 5 or is equal to negative 5. Another example, 5 absolute value of x minus 4 is equal to 26. So first, we will add both sides by 4. It will lead us to 5 absolute value of x is equal to 30. Then, divide both sides by 5, which leads us to the absolute value of x is equal to 6, which means that x is equal to 6 or is equal to negative 6. Now, in solving equations with an absolute value, always remember to solve everything inside and remove the bar sign. For example, the absolute value of 2x minus 1 is equal to 7. We have to solve for two equations to find the possible values for x. Our two equations will be 2x minus 1 is equal to 7, or 2x minus 1 is equal to negative 7. So let's solve for the positive value first. 2x minus 1 is equal to 7. Add 1 in both sides, which leads us to 2x is equal to 8. Then divide both sides by 2, which leads us to x is equal to 4. So that is our first answer. Our second answer will be 2x minus 1 is equal to negative 7, and we add both sides by 1, which leads us to 2x is equal to negative 6. Then divide both sides by 2, which leads us to the answer that is x is equal to negative 3. Therefore, in this problem, we have two solutions. X is equal to 4 or x is equal to negative 3. That's all for this video, study buds. Goodbye!